Hey kids, Mr. Little again. Hey, I'm going to go ahead and go through the process with you for the virtual lab that's been assigned for week 4. You may want to go ahead and use this to help guide you. I figure there might be a little bit of confusion going on, but if you need to watch something so you can visually see what's going on, that is what Miss Lovern and I are here for. So if you look at the instructions when you open the document, it says when you open the virtual lab, first look at the left and read while scrolling down. So I'm going to go through this step by step. So I'm going to go ahead and I'm going to click on this part right here. Okay, this is the part that I'm going to click on that's going to bring up this guy that looks like this. Okay, now I'm going to go ahead and read through this part right here, and let's see if I can get, oh good, that's going to work out well. I thought I didn't have my screen set up correctly. Okay, it says, ocean motion. How are tides affected by phases of the moon? Earth's motions are constantly in motion. The periodic rise and fall of the surface levels of the ocean are known as tides. A tide is a giant wave caused by gravitational attractions among the sun, moon, and earth. High tide occurs when the crest of the wave approaches the shore and the sea level rises. Low tide occurs when the trough of the wave, or the low part, approaches the shore and the sea level drops. A cycle of 2 high tide and 2 low tides takes slightly more than a day. We look at it as about 2 high tides per day, 2 low tides per day. The moon's gravity exerts a strong pull on Earth. The water in the oceans responds to this pull. The pull of the moon's gravity is slightly stronger on the surface of Earth that is closest to the moon. Water is pulled up toward the moon as Earth and the moon revolve around a barycenter, or a common center of mass between Earth and the moon. A bulge of water forms directly under the moon as the water closest to the moon is pulled towards the moon. The rotation of the moon and Earth around the barycenter also causes a bulge of water on the side of Earth opposite the moon. On the far side of Earth, the pull of the moon's gravity is weaker. Earth's spinning produces a force much like the force that causes a spinning ice skater's hair to fly outward. This makes Earth wobble slightly as it revolves around the barycenter. The wobbling action propels the oceans outward, causing a bulge on the side of Earth opposite the moon. As Earth rotates, the tidal bulges remain aligned with the moon. Every location on Earth passes under both tidal bulges and thus experiences 2 high and 2 low tides each day. The sun also affects tides. When the moon and the sun are aligned, their combined gravitational forces result in high tides that are higher and low tides that are lower than normal. These tides are called spring tides. When the sun and moon are not aligned, the gravitational forces counteract each other, causing high tides that are lower and low tides that are higher than normal, and these are called neap tides. In this virtual lab, you will measure the height of high tides and low tides during 4 phases of the moon. You will determine how the different phases of the moon affect these tides. Objectives. Measure the height of the 2 highest and 2 lowest tides during 4 phases of the moon. Record the highest high tide and lowest low tide for each phase of the moon and interpret a graph of this information. Compare the influence of each phase of the moon on its tidal range. Okay, I'm going to skip back to the instruction template. It says the steps to run the lab are in the procedure portion of the reading. So if I go back to the lab, that's this part right here. Okay, try to get it all centered on my screen. Looks like it's going to be a little too long. That's okay. Procedure. Number 1, select a phase of the moon by clicking one of the 4 circles around Earth. Notice that Earth is shown from a view directly above the North Pole. So remember, these are the ones that we're looking at, these 4 phases of the moon. Remember, SNEF, sun, new, Earth, full. Okay? And then you should be able to remember which of these phases are which. Okay? Examine the calendar to find out when the selected phase of the moon occurs. The phases of the moon are abbreviated as follows: NM standing for new moon, FQ standing for first quarter, FM for full moon, and LQ for last quarter. You'll observe the water level at 12 a.m. Click the hourglass to begin the day's tide cycle. Observe the rise or fall of the water level for 6 hours of the tide cycle. Then, read the measurement after the water level has reached the first low or high tide of the day. Record it by clicking on the up and down arrows to scroll through the measurements. Click the hourglass again and collect data for the next 6 hours of the tide cycle. Repeat this step until you have collected data for all the high and low tides. Right, kids? Remember that we get a high tide and a low tide separated by about 6 hours. 12 hours between two comparative high tides, 12 hours between two comparative low tides. But the difference between a high tide and the next low tide is equivalent to 6 hours. Click the check button. If a measurement is recorded incorrectly, it will be highlighted yellow. Click the panel with the highlighted measurement and examine the water level. Click the up and down arrows to select another measurement. After you have correctly measured the 4 tides, compare the 2 low tides and the 2 high tides. In the table, record the highest tide and the lowest tide of the day for the selected phase of the moon. Click the graph button to see a graphical representation of the data. Repeat the virtual lab and collect data for each of the 4 phases of the moon. Complete the journal questions and click the new location button to get a new location. Now, the first thing that we need to do, notice that this image is on Seaside Wharf. We can't even begin because if you go back to the instructions, it tells you that we are interested in one location, Pete's Pier. So we're going to go back here, and if I scroll this down just far enough, you can see where it says new location. So I'm going to click on that until I get to Pete's Pier. So you may have to go through several instances of this. You may see Snug Harbor, Seaside Wharf, but what we're interested in is the Pete's Pier, which is right here. So basically what it's telling you to do is if I go ahead and click on this one, which is equivalent to new moon, you can see that on April 7th, right, it's got it highlighted and it's notating it as new moon. If I go ahead and use the hourglass, click on it, I should see what happens to my sea level. Okay, so you may want to go ahead and adjust the timing as necessary, but you'll see that at 1:46 in the morning, I get my first low tide. Then it'll ask you to go ahead and click on the hourglass again and see the results. Really just follow the instructions on the lab and make sure that you are making a copy of this and filling this out as you go. Okay, it also provides a little bit more examples in terms of instructions for calculating the tidal range. So if low tide is below sea level, I add the numbers. If low tide is above sea level, I subtract the numbers and so forth. So once you finish that, you want to hang on to it, okay? But you're going to go ahead and find another form that looks like this: Virtual Lab, Ocean Motion Results and Conclusion Questions. You'll put in your first and last name, you'll enter your class period, you'll put in what was the highest tide in meters at Pete's Pier. Remember, numbers only, we don't need any kind of units. You're also going to answer during which phase of the moon did the highest tide occur at Pete's Pier. We'll scroll down here. You'll use your data to match up each moon phase with the greatest tidal range that you calculated from the 2 high and low tide sets. Okay, so these radio buttons you will go ahead and fill in appropriately. I'm going to scroll down a little bit more. Next it says, which type of tides have the greatest tidal range or the biggest difference between them? Spring tides or neap tides? If you are paying attention to the textbook and the oral lecture, that should be a pretty easy question to answer. According to your data, which 2 moon phases had the greatest tidal range? Again, if you looked at the oral lecture and the textbook, this one should be easy peasy. Is it new and first quarter moon phases, first and third quarter moon phases, the full and new moon phases, or the full and third quarter moon phases? Okay, scrolling down, get the next couple questions up. The greatest tidal ranges occurred during a new moon. Which statement best explains why? The Earth's gravitational force acting on the ocean water lessens when the moon and sun are in alignment. The tidal force exerted by the moon is strongest on the side of the Earth facing the moon. When the sun and moon make a right angle in relation to the Earth, the gravitational forces combine. Excuse me. Next question, approximately how many hours are between one high tide to the next high tide? So we're going from one high tide peak to the next high tide peak. Would it be 4 hours, 6 hours, 12 hours, or 24 hours? Next, how many tides occur in the time it takes the Earth to rotate once? Remember that the rotational cycle for Earth to complete one rotation is 24 hours. So how many tides are going to occur in that 24-hour period. Look at the graph below. On what dates did a neap tide occur? Make sure you study the graph, kids. Make sure you notice that there's 4 dates that are given. Their low and high tide bars are provided for each of those dates, and their height in feet. Did it occur on January 10th and 17th, January 17th and February 2nd, January 10th and 25th, or January 25th and February 2nd? Okay, we're going to use the same graph. On what date did a new moon phase most likely occur? Remember what type of tides we get during a new moon phase. Okay, again, study the graph and answer the question. When is the most likely date that I got a new moon phase? Would it be on January 10th, January 17th, January 25th, or February 2nd? Once you've completed each of those items, make sure that you click on the send button. A lot of kids still, they answer the questions, but they fail to hit that send button. And then when the teacher asks, hey, I didn't get your work, you're like, whoa, I did the work. Yeah, it's probably because you may have forgotten to click the send button. So this concludes the virtual lab over Ocean Motion. And if you have any questions, make sure you email either Ms. Lovern or myself, or you may attend one of our tutorial periods if you feel that that is warranted. Have a great day, kids. Talk to you soon.